Okay, I think we're live now.
Perfect.
Okay, cool. Hello everyone, I'm Saqib. Along with me is Saad. I am the AI lead and founding engineer at Langbase. And today I'm going to talk about some of the agent architectures that we have observed and we have seen customers using in production that actually help them build scalable AI agents. And I will let Saad introduce himself.
Yeah, so hey folks. So my name is Saad. I am a founding engineer here at Langbase. I'm a full stack engineer, and yeah, I am working everywhere in every part of Langbase, whether it's engineering, dev. So yeah, that's a brief introduction of who I am.
Cool. Saad, we are live both on YouTube and X, right?
That's perfect.
Cool. I'm gonna just quickly share my screen and briefly go through what we're gonna talk about today. So, if you go to langbase.com/agents, you would.
Saqib, I think your screen is not showing up on the stream.
Oh, wait.
Now it
Sorry.
is.
Right? Okay. Cool. Thanks. Okay, so if you go to language.com/agents, you will find these agent architectures. These agent architectures are built from bare bones. They are not using any framework, um, any bloated piece of software out there, but instead they are built from the bare bones of LLM that you would need, that you actually need in production to build scalable AI agents. So I'm gonna quickly start with an overview of what we call an LLM in this context or a simple agent. That's something we call pipe in the context of Langbase. So essentially, an LLM, anything out there by the proprietary or one of the open source one, has this LLM piece. You get an input which goes into the LLM and you get an output. But that's not enough in practice. So what we need is bunch of tooling around this to actually build agents that actually do some work and scale. So with along with LLMs, it has access to tools. So it allows you to communicate and make actions in other applications that are connected to your LLM, whether it's Slack or any other tool calls that maybe you're sending emails and checking emails and whatnot. And then it has this thing called threads, where it's conversational memory. So you start your chat and bunch of messages are going on, and you have to maintain those things and then keep sending them back to LLM. So it has all of the memory of what your conversation has been so far. So it needs an access to threads. Sometimes it's also called memory on the internet. But what actually memory is the long-term memory that is actually memory of your documents and your data, which LLM is not trained on. So that's something that you actually want to supply to your LLM so it can actually answer your queries tailored to your data. So that onwards when we talk about LLMs, so that's what we mean. That's what Anthropic calls as augmented LLM. And in order to build an AI agent like using augmented LLM, it is as simple as this: using your language API key and creating this. You need to specify your name and you need to specify the model, one of the hundreds of models available out there, and then you just pass system prompt and to get started. Once your agent is created, all you need to do is run it. And while running, you need to pass your agent name, and then you just pass your input text and you get the output. So for instance, if I go ahead and run this agent, it gives me a summary of the blank-based description. So what it's doing is essentially we are creating a summary agent and we are configuring it with a single system message that defines its role here. We simply say, hey, you are a helpful assistant that summarizes our text. Next, what we do is we run this agent and we just simply pass the name, and we pass the input text, which in this case is this huge description of Langbase. And once we run it, what we get as an output is a short summary of what Langbase is. So that's a quick basic introduction of what an augmented LLM is, what we call an LLM in our agent architectures. Um, Moving onwards, what I'm gonna talk and focus during this live stream is two agent architectures: prompt chaining and composition. Prompt chaining is essentially chaining bunch of LLM calls in a sequence. And the goal here is the task that can be decomposed into simpler and smaller tasks. And another important thing is the output of the previous LLM call. For instance, here you
Sakib,
see input is coming
uh,
in, get output one.
Sakib,
Yeah.
Sakib, maybe we could take a step back here. And sorry, I'm just joining the stream. Maybe we could take a step back here and start a little bit about talk a little bit about why all of the best AI agents are actually not built with frameworks, right? Before jumping into chaining and composition, like I think it's important to understand. Like for example, if we look at a lot of recent really good agents, look at Cursor, V0, Bold, Chai, Lovable, and a bunch of others. There's one thing in common in all of these agents, and that's the commonality is that none of these agents are actually built on top of an AI framework, right? This is like it's a huge pattern, right? When I look at this from an engineering point of view, it's always like, why are they not using any AI frameworks? Do AI frameworks not work? And most of the times, why are all these agents built with TypeScript? Most of it, like I'm sure the back end of Perplexity and Cursor is probably not in TypeScript, but eventually the agent that you are interacting with, the on the browser side, that's all TypeScript, right? And a lot of it is actually TypeScript, right? But maybe let's start to unpack this first thing. Why somebody like all these companies are choosing not to use an AI framework? Like, what's your pick on that?
Yeah, I think that's a good starting point. And couple of things that I have noticed in practice is one, they introduce this unnecessary layer of abstraction, which is not required. I mean, sometimes it's good for speed, but usually what I have seen is because APIs are changing so quickly and new things are coming in like MCPs. And yesterday, I think Google introduced A to A thing. It becomes very hard to integrate and use those with the pre-existing frameworks. And they do not usually evolve at the rate at which AI is evolving. And what happens as experiment to start quickly, you would find yourself scratching your head and finding ways around just to integrate the new things. And that's likely not what you're looking for when you start building with the framework. Um, so
maybe
I think
maybe maybe let's unpack this abstraction piece, right? So like for those of you who know me, I've been around the block for quite a while now, 25 plus years since I've been writing code. And I've contributed literally everything related to web, right? From contributing to the original stack of HTML5 to PHP forms to then core infrastructure that web is now built on top of React, getting Facebook to open source React back in the day, in then Next.js, Node.js, and then being on the technical and community committees of Node.js. I've been around the block. I've seen frameworks being built from the grounds up, right? And there was always one thing common in these frameworks, right? There was definitely no LLMs, right? So nobody was writing your code. So a lot of developers actually built frameworks, and we used to call them boilerplates, or starter kits, or frameworks of abstractions. Basically, the reason behind that was they would reduce the amount of code you needed to write, and they would make things a bit faster for you, right? So, for example, React. Let's take a look at React. So React was built because the DOM, the API that connects JavaScript to your HTML, all of the elements on the document object model, that was different for different browsers. This is also why we had jQuery back in the day, right? to create a layer of abstraction. So you would just write one piece of code, one layer of code, and should potentially work in all browsers. React had a different idea. React was like, what if we created a shadow DOM, right? That you would write to, and we will write a framework that will interact with the shadow DOM and DOM, right? And as we all know, this became a thing. It's super super powerful. React ended up building components and whatnot. So a lot of people then thought that React was pretty awesome, and then they started building uh, frameworks on top of this. Right? We have seen some of the big names, Next.js, right? We have seen, I think, in recent years, Astro built something around it. There's also obviously Wheat. There's I think my friend. Tenor built 10 stack, right? Um, 10 stack start, right? And there are a couple others as well, right? But what's happening here is that these frameworks are being built for many reasons on top of React. React remains this amazing, stable foundation for all of these frameworks. But for a minute, if we were to replace all of this with the current situation we are in, the foundation people are trying to build frameworks on top of are LLMs, uh, and LLMs meaning their APIs, which are always changing, right? And then there are all new standards coming in, popping up, looking at you, MCP and A2A, right? So like all of these things are changing a lot. On the other hand, React, I if I'm not wrong, if my recollection of loss isn't misleading me, I think React had like maybe less than five major updates in the last 10 years. Again, super stable foundation, right? But if you replace this with something that is almost changing every other week, there's a new LLM every other week. Like you go to where you wake up and there's Grok 3, and then there's, like experimental models around or whatnot. Any framework that you build on top of this becomes what I call a lang pain, right? It becomes painful to update it. It becomes painful to keep it updated. Really hard to make sure that it's not always breaking the cloud that is needed to build for this, or the server that you are building to scale all of this becomes an issue. So the very problem that a framework wanted to fix all of a sudden becomes a bigger problem. Right now, you need a team to manage all of your framework DevOps, its updates, its backward compatibility, and this and that. All while this new paradigm is true, where AI is writing, let's say, 50% of our code, which is again, it's writing a lot more now, right? I remember back in the day, like I think 2022 or 2021, when I had access to GitHub Copilot, and I tweeted that I think 50% of my code is written by GitHub Copilot now. Not a lot of people believe that, but this is much believable now, right? So when AI can like write the code for you, like for example, Next.js was built because nobody wanted to write, Webpack code. But if AI was there, I would just write a Webpack code. I'm like not saying that Next.js is not great. Next.js is awesome, but I'm just saying that a lot of developers would not go through the pain of configuring the underlying config files, the Webpack configurations, and this and that, the React router stuff, because AI just can really help you write a lot of code. But if you start building a framework, all of a sudden you're married to whatever their problems are, right? And if it is not a stable framework, which we have seen again and again, no framework in this space is really stable, it becomes an even bigger problem. So a lot of developers are then moving into the space of what I think Shared Scene kind of pioneered. Right? Shared was like, let's not build a framework. Right? Shared was like, I'm gonna build some components, and you can just copy paste these components. We call this a copy paste pattern, right? Only if I can type correctly. uh, and you can just copy paste this component, change their shape or whatnot. If I update something, it's up to you if you want to update it or not, right? And this is very similar to primitives approach, which has happened before. Like, I remember very clearly there was this S3 moment, right? When AWS launched S3, all of a sudden, object storage was a thing that you didn't have to deal with, right? You got a simple API from S3. You uploaded your files and you could download your files. That was it. You didn't have to deal with, streams of data. You didn't have to deal with sharding, this and that. And this primitive actually made AWS what it is today. AWS is filled with a lot of primitives that a lot of these companies now use, right? So what I'm trying to do is I'm trying to build a case here that maybe conventional engineering wisdom is not okay in this new form of engineering where AI is helping you write a lot of code, where new patterns are emerging, new standards are popping up left and right. Maybe we could just skip the frameworks. And like if you go to our agent architectures page, you will see that we've built a lot of architectures here that can help you build maybe 80% of all of your agents you want to build, right? 80 is still a very reserved argument. I think I have not like I've built like what thousands of AI agents in last couple of years. We're scaling to about 100 million runs a month. Zero frameworks were used, right? So uh, it this thing that you can just do without frameworks and just use pure primitives that are hosted AI native, purpose built AI native primitives, like this augmented LLM that we chose to call Pipe. Pipe is the OG MCP, by the way, right? If you know what an MCP is, and remove the weird protocol stuff, that is a pipe, prompt instruction personalization engine. It has access to tools, memory, and threads, right? This is a good enough primitive to help you build anything. I like now. I'll probably leave it to Saqib. Saqib, now I think with this introduction of why we are building it this way, I think what Saqib's probably going to talk about now is how you don't need a primitive, how how you don't need anything more than a primitive, how you don't need any framework. You can just use plain old JavaScript, TypeScript, Python, whatever you want, with a very simple primitive that gives you API that looks like very similar to OpenAI, but on top of 600 LLMs, right? So I can go ahead. Let's talk about. And by the way, if you have any thoughts on what I just blabbered around about, let us know.
Yeah, no, that's true. I think one other issue that arises is because of this ever evolving landscape is you are at the mercy of that framework until they support it. You cannot literally integrate that, and since you have built your whole application on top of that, you cannot just scrap it off. And what happens is you usually try to find workaround the framework and then try to see how you can make it work, right? So that's usually what ends up happening.
Architecture now.
I think you were not on the
Oh yeah,
screen.
I was doing something. Go ahead. Yeah.
Okay, cool. Yeah, I'm gonna move ahead and talk about the agent architectures and walk you folks through some of the examples and how powerful these basic primitive based agent architectures are, and how you would really not need a lot of these blotted framework code to actually build things. I'm gonna quickly switch the screen. Okay. Okay, cool. So I'm gonna start with this prompt chaining architecture. So essentially, the case for this design pattern is if you are able to decompose your problem into series of steps, um, where you define bunch of LLM calls, but each of them is essentially just doing one thing and doing it really well. Um, and then output of the previous call is being fed to the to the next LLM. So if you see here from the start, we have this input coming in, which in your case would be a user query or whatever params that you're using. It goes to the LLM, you get an output, and then there's this gate. So this gate, think of it as not just one step gate, but it's like this gate could literally be attached to all of these LLM calls. So this is sort of a sanity check, right? Just like any of your piece of code that you write, you do something and then you want to make sure, hey, the output that is coming is actually correct, and you want to only proceed if it meets a certain criteria. So in this case, it could be this gate, and this gate here could be anything. It could be a traditional neural network doing some sort of classification, or just an if-else statement, literally. Or this gate itself could be another LLM, maybe an expensive one that you can trust to actually check your output and give you, hey, you want to proceed and you don't want to proceed. And you can exit, or send a notification to user and whatnot if it fails, right? But if it passes, then what you're going to do is you're going to feed this output to the next LLM call, and this goes on up until you get your final output. So that's the basic idea behind prompt chaining and composition. And now I'm gonna walk you through this simple example. So what we're gonna do in this example is essentially implement a sequential product marketing content pipeline. So essentially what you get is you give a raw product description, and then the second stage gets a summary out of it, and then you have another third agent which writes this salesy and marketing copy for your product. Um, I'm gonna quickly walk you through this overall code, and then we're gonna live code this. So essentially, as Ahmed mentioned, very basic primitive level approach. What you will see here would not be any bloated or fancy code that you see most of the time on the internet, especially around the AI space. It's just basic JavaScript or TypeScript, whatever you want to call it. And then you simply see we have defined these bunch of steps. Each of the step we define this model that it's going to use. And the cool thing about this thing is you can actually use a specialized model for each of those steps, right? Because some models are good for some things, and not one model is good for everything, right? For instance, Claude is really good at coding, right? And then you have reasoning models to actually reason about things. And you could have this prompt chaining thing where you can start with the planning step, right? You could be using O1 or O1 Pro to actually plan all of the things that you want to do. So you get a really nice outline and a plan of what your agent wants to do, and then you can feed that into the series of LLMs to actually do the rest of the work. But for things like summary, you don't really need a very expensive LLM. A simple and very cheap model like Gemini would do a really decent job, such even similar to like some of the high end or expensive models. So simply a bunch of steps are defined. I'm gonna go through all of them in the code. So I'm gonna quickly do a walkthrough. We go ahead and create all of those agents. They are created in Langbase. Nothing fancy, just a promise.all over all the states. And then we're gonna do a simple four step, a loop on top of that. We get an output, we take that output, and then we pass that as an input to the next step. And I have put a simple check here where I want to check the summary that is being generated in the first step that is not too short. Because maybe there is a requirement for the marketing stuff. Hey, the summary should have at least 10 characters or 10 words. So that's just a simple check here. Now I'm gonna move on to the coding for this prompt chaining part. Meanwhile, Ahmed, do you have anything to say on that while I just set up and switch to my environment?
Yeah, sure. Go ahead. Uh, I'll probably share my screen. Uh,
Cool.
okay,
Uh,
there you go. Yeah. So bunch of steps, very basic steps are happening, right? What we have done is we have built an array of what are going to be agents. We This is a summary agent with the description of what this does, a feature agent, in a marketing copy agent. And basically we are going to run all of these with, because this is JavaScript with, simple JavaScript language, right? Using this code, we are going to step over all of these steps, which in our case are agents, and process all of the user input, right? And the user input is this giant big text, right? And Sakib, correct me if I'm wrong, but what we are doing here is we are summarizing all of this.
So essentially, we're generating a marketing copy for a product.
Oh,
We
okay,
get
okay.
the raw description, and then it
Yeah, yeah,
goes
yeah.
through the steps to
Yeah,
generate a
yeah, yeah.
product copy.
So first step is just to summarize what the user is saying. Second step is to understand the key ideas in bullet points, and finally, write a marketing copy. Pretty standard task, pretty simple to do. But just to give you an idea, we are using three agents for this, right? So these are the three agents: summary agent, feature extraction one, and the marketing copy one, right? We are gonna run all of these here. The marketing copy that is going to be generated is going to be about smartwatches and their versatile device featuring or something like that, right? And then we are going to step over all of these. We're going to run all of these LLMs, all of the pipes. Pipe is, in our case, like an MCP. Pipe is an agent, right? And we are basically going to send it all of the user data in the step, right? And then it is going to produce the summary, the features, and the marketing copy, which if I were to run it now, you will probably see the final response right away. So this was the summary, right? So the summary description creator agent wrote this. Then this was the extract features agent, right? Which extracted all these features, which should be in the marketing copy for the input that the user was asking for, right? And finally, we are going to feed this and the summary into the final, agent, which is going to refine the marketing copy based on that, right? So it's like multiple agents working together to fix small problems, right? And I can probably zoom in a little bit. I just saw this, but you can see that this is being uh, for example, if I were to look at sleek design, right, you will see that sleek design is bold here, and it's definitely getting a mention here, right? And design for everyday use, right? So basically, this refined marketing copy agent is actually using those features that we extracted to write content in a much better way, in a way that we actually want it to do, right? And you can apply this to anything, right? You can compose and chain or pipe different LLMs together. I generally think that you should only, when you send an LLM a message, you should only try to make it do one thing, not a lot. Especially with negation, the moment you say something like, don't do this, it will also try and not do other things, right? It's a pattern that a lot of people skip over. So you should, it's going to cost you the same, right? The cost is not an issue. You do want to send multiple requests and distribute them across a small set of agents, and then kind of synthesize all of them into one final agent. That generally works really, really well, right? I think Sakib, you're all set with your setup now, right?
Yeah, yeah. One small
Okay.
thing I want to add is when we actually in practice ask LLM to just do one thing and do it and only one thing really well, it actually does it really well. Instead of giving or telling it like 10 things to do and then this and then like description of 10 things and restrictions, hey, don't do this and this thing, and but you're allowed to do this thing in the second part, and in third part you're not allowed to do thing. What you will see in the output is it's doing one thing in the other part and second thing in the first part. And that's why you scratch your head and you're like, it's hallucinating, it doesn't work really.
Yeah,
So
yeah, yeah.
that
So
atomic approach is
basically,
actually helpful there.
yeah, yeah. So basically, just to illustrate, this is what Sakib is saying. Don't make an agent that tries to do a lot of things, like don't make an agent that summarizes and writes marketing copy and does this and that, right? Especially when you have like something negation, like don't do this, right? Most of the time, don't do this, right? Don't do that, don't. Most of the times this information works really well if it is separate, right? So in this case, you will probably split it up into multiple agents. You'll summarize the input. Let's say you get an input, you'll summarize, and then you'll send this summary to another agent that will do one thing. So both of these agents are sort of atomic. You don't have to go crazy on this. Like, don't repeat yourself. Like, feel free to add, test it out a little bit. Vibe check, as we call it. But distributing your task across multiple set of agents, multiple set of calls, actually improves the output really, really well. Right? Like, go ahead, Sakib. I'm probably gonna
Yeah,
hide my
I'm
screen now.
gonna just share the screen. Okay. Um, I have a basic Node project setup here to walk you through packages and
Mhm.
file. Nothing
You
fancy
might
going
want to
on.
zoom in.
Okay. Is it good now? Okay, wait. Should be good now. Okay. Hmm. Nothing fancy going on here. Just .n and Langbase SDK. That's all. Just types, and that's all we need for this setup. And I have this .in file. You need to put your Langbase API key. You can obtain one from the docs API reference and API keys here. I'm gonna leave those links later on, so you don't have to note it down. So all I have here is I have imported Langbase .env, and then I'm just passing, creating a client of Langbase, just passing the Langbase API key, the steps you just saw. I have summary agent, I have feature agent, and then I have marketing copy agent. So just all of these agents. And then I'm gonna go ahead and use the SDK to just create all of those agents. I'm gonna comment rest of the code for now so we can see step by step what is going on there. Okay. Just one. Okay. Cool. Okay. So I'm gonna just run it. Prompt chaining, and it's just gonna run this file. It's going ahead and it's creating pipe. All of those pipes are created. Once they are created, they are available in the Langbase dashboard. You can also use the list endpoint to actually go and see if all of those are created. Next, what we're gonna do is we're gonna actually use all of those agents that we just created. So all of those agents are live now. Just a minute. We need to uncomment this. Okay, cool. So now we're gonna call all of those agents, just iterating through all of those agents here, passing out the instructions, and then data that comes as a response. I'm going response dot completion. I get the response, and if the step is summary step, I want to put a gate here. I want to make sure that the summary is not less than 10 words, right? So if it is less than 10 words, I don't want to continue. I just want to throw an error here. So that's what it is doing here. Simple check, not a fancy guardrail, not a fancy safety check or all those jargons, just like the basic programming if condition, right? That you would want to put. Nothing fancy going on here. And then otherwise, I just log that it is valid and we are good to go. And then this goes into the loop and we get the final output. I'm gonna now go ahead and run it and see how all of these steps perform. Okay, cool. So we have first step, that is the summary one. We have input going into this, which is the smartwatch. Smartwatch is the versatile device featuring high resolution display and other properties or the data about the smartwatch. And we get the response out here for the summary agent. And then we perform the check, which is the gate on it. Where we basically just check, hey, it's if it is 10 words or not, and we can clearly see it is, and then it says, hey, the output is valid, and we're gonna go and continue to the next step. um, and then next is the features agent. What it's gonna do is it's gonna take it in that summary and the raw input and gonna write all of these features, so something that you would usually see in the marketing copy. And then we're gonna feed all of those to the marketing copy agent, and then it's gonna generate this final polished output. So now we see all of those features going to the input, and then we see response, where it just talks about all of those features. So it went through a series of these steps, and we started from this raw description here, and we have our final copy that is ready to go. So that's basically the gist of very basic chaining architecture, which usually looks very simple, but it can really do powerful things if you put in proper checks and you do powerful LLM chaining. For instance, maybe each of the step in this architecture here, it can be paired with an evaluator. So once it is generating output, instead of just doing and giving the output to the next step, what you can do is you can loop it with an evaluator which evaluates, hey, whether it's sufficient enough or good enough or not, and then you go to the next step. Or maybe you want to do a human in loop sort of thing, right? Maybe a sport ticket comes in, you do bunch of analysis, one of your agent goes and pull in the user's old data, and then another agent does bunch of analysis, and then hey, it identifies, hey, it's a critical thing, it's a critical query coming in, and then it can just go and send notification to you, and then you can actually review that. Once you mark it, the human in loop is gonna the loop is gonna complete, and then you can continue the next step where you're gonna have an output and you can actually send it to the user. So that's basically what prompt chaining does. Next, what we have is
Sakib,
agent routing. But before we go there, yeah.
so there are a couple of questions I think we should address now, right?
Okay.
One is Yasser is actually asking what are we actually trying to achieve here, right? So like overall, if we could catch up the what the goal is, right?
Oh, okay, cool. So essentially, I think he missed the opening where we actually introduced like how framework based approach are not working. How if you develop using a framework, it usually and quickly leads to this bloated app, where you are at the mercy of the vendor of the framework, where you have to wait on them to actually introduce the feature that are coming out. And particularly in the AI space, where it is evolving very very quickly, new things coming out literally every other day, like MCPs and A2A and whatnot. You really don't want to bet on those things. First, you lose the control due to this abstraction and just for the sake of moving fast. And in the long run, you actually find yourself spending more time on the framework, figuring out the things instead of, just
And
taking the control and doing it.
very simply, basically we are trying to show you a most one of the most common architectures when you are trying to make multiple LLMs, multiple agents work together, right? So there's a relevant question to this, like, is it open source? How do we make it work for building an agentic workflow? I think what would really help people is if we also showed them that the code is simple enough, our SDK is open source, but this is how you deploy it. And now it's deployed, it's online, and you can it is gonna automatically scale. You are only writing the logic, the code behind it, the logistics, DevOps, infrastructure that will automatically get provisioned for you when you're on Langbase, right? So let's maybe take this there. We just built 3 agents. They are able to do these things.
Mhm.
How about we deploy them and take them online?
Oh, they are all deployed already. I'm just using the SDK, so they are already live. I'm gonna just go
Yeah.
to the
How about
studio
we show
and
the
actually, yeah,
deployment part, right? So how somebody would actually go and do that, right?
yeah. Okay, I'm gonna just go into. Do you want me to show the studio, or it's just like the?
Do you want me to show that because I have it right here?
Sure. I need to open that. I have the all the coding screens open next to me.
Oh, okay, okay, okay. So you will basically go to langbase.com. You'll sign up, right? So, and then you will land into the studio, right? And you don't actually have to come here to do any of the work, but it does really help if you are here, right? So if you were to actually go to the overview of examples in our docs, we've created a lot of examples here. Like how do you create a pipe, run a pipe? How do you create a chat agent? How do you start streaming? How do you run tools with your agent? all of the fun stuff. And then how do you deal with memory, like how do you add filters or citations into a memory, a memory is our rag engine of sorts, right? And how do you deal with threads, tools, and a bunch of other things like chunking, parsing, or whatnot, right? So all of this is here. The very first step is to basically create an agent, right? And that you can do by simply langbase.pipes.create, and you will probably give it a name and a state if it is private or public, right? And you'll definitely use our API key, right? This is what you get when you go or when you log in. You can create an org here if you're an organization, or you can just use your personal account. You will basically go ahead in settings, and then Langbase API keys, and this is where you can get your API keys from. And then once you create a file like this and run it, it will basically create an agent called summary that after this you can actually go ahead and use, right? So if I were to go back and I want to run the pipe, I would probably run that pipe using that same name. So here's the name of that pipe, right? And now langbase.pipes.run, I'm actually running that pipe with a bunch of more information, like messages from the user, like who is an AI engineer, right? How about I actually quickly show you what it looks like in Studio? You can also do that in Studio. You can create a pipe. Let's call it I don't know, summary for workshop, right? Workshop. And you can keep it public or private, very similar to a GitHub repo. You can again create this agent through our SDK or through our studio. Once you've done that, this is what it looks like in our studio. You can start adding your system instructions here, and you can start chatting with this agent, right? So, for example, uh, if I were to just copy this, who is an AI engineer, ask it here, you will basically see, uh, it will probably respond. This is an AI engineer. There's a response, and you can, see all of the fun stuff here. Right now, the streaming is on, so it is streaming, and you can have like 600 plus LLMs now, right? Right now, this is GPT-4o mini. You can pick something else. Our API never really changes, right? You can deploy a new version. So, for example, if I were to change this, like this was a very lengthy response, right? I don't want a lengthy response like this. I'll just say always be less wordy. I want one liners. Uh, Tone could be Ryan Reynolds, right? So I'm sure this is going to be fun, right? So if there you go. So if I were to ask who's an AI engineer, now I'm gonna get something really well, right? So AI engineer is a tech wizard who builds smart machines, thinks, and learns, maybe even tell jokes one day, right? So see how simple this is. I can now switch from this LLM to, I don't know, Gemini. Let's go with Gemini 2.0 Flash. I can then clear this, run it again, and you will see that this response will probably be way different because this is, you know, a different LLM. But eventually, behind the scene, what's happening is you now are experimenting in creating a very simple agent here, right? It can have variables, tools, safety, or whatnot. You can save it as a sandbox. You can deploy it to production. It will basically get deployed. And then on API, it's very simple. Now you will pick up the API key and you will use this same code, which has the API key in here. You can, send this who is an AI engineer here. You can run it. This is the API code that will eventually run on our infrastructure. You don't have to worry about this agent now. You can send it like, I don't know, 100 million messages a month and it will still work. We will automatically scale it. And you will basically be just writing code, very simple logic to build multiple agents, right? So what Sakib had done in this example was in the agent architecture prompt training examples, he had created multiple agents, right? And he was just using them, right? So I think because I saw one of the comments where some of the, I think it was from Arib, I felt like it's the deployment part was not clear, right? And now, by the way, I can actually go to the usage tab. I can quickly see, this is the amount of money I've spent. If I were to send a million requests, I will probably end up paying $66. And this is overall, right? I have been changing the models, right? So it's basically predicting what that would look like. I can also see the latency. I can actually go deep down into all of these runs and see, what the prompt was, what the user sent as an input, what the completion was. If you are dealing with something sensitive, you can actually set store to false, and it will not store this, right? um yeah, I think that's pretty much it. Like, just to quickly catch you up, that this thing exists in a way like this. If I were to change it to, I don't know, tone could be Ahmed, you can see it has already created a draft fork, right? And I can deploy it as a new version. But if I were to run it now, so who is an AI engineer, you will see that the tone changes to to something what Gemini thinks is sounds like me. But if I were to go below in the runs, there's a happy path that we have created for you, right? So this was the run that just happened in the playground. You can come in, see all of this. You can send this to one of your colleagues, right? And they could jump in here and they could see, okay, this was the question, this was the answer, this was the stats or whatnot. Seems pretty good. What was what were you doing, right? And they can jump into this preview version that was created for this experiment where I was saying tone should be MOS, right? Because if I were to like quickly just refresh this, right? Because I haven't saved anything, right? It was just a draft fork. It will basically go back to the production version 2, and the tone will be Ryan Reynolds, right? There you go. But on this side, on this preview, the user has access to my experiment where I had changed the tone to MWS and I've changed the LLM as well, probably. You have the choice to save it as a sandbox, right? It will be saved as, I think, as a sandbox version 3. There you go. And you have the choice to deploy this as well into production, right? And when you deploy this into production, this instruction and this new agent will be provisioned in milliseconds. And now you can just keep using the updated one. So you can continue to version it. You have the control over all the versions. Like if I were to compare this with production version 2, you can see that from version 2 to version 3, the only change is Ryan Reynolds is now Ahmed West, right? So we have this collaboration path built for you. We have the entire power of our infrastructure platform built for you. Any agent that you build becomes an API that you can use with our SDK or with our API, with any language really, or our JavaScript, TypeScript SDK, right? Okay, I think I've spoken a lot on this, but I'll let you share more, Sakib.
Cool, thanks. No, I think this is super helpful. I think some of the viewers had basic questions around Langbase, I guess. So that's helpful. Thank you. I'm gonna move next to agent routing, another very powerful architecture that you might have seen in production already or might be using it. So the idea is simple. You design a dedicated LLM to do just one thing. You do not want to optimize one for everything. But you know that the actual thing that you're gonna do is just one step or whatever. And then you have this LLM router here. User's input comes in, and then this router part it does decision making. And then based on that, you send the query to an appropriate LLM. So, for instance, think of a very basic customer support setup. Let's say a query comes in related to maybe your dog, so just pricing or technical stuff, right? We have this one LLM that just knows about that. It's public data, non-sensitive. It's out there. It has all the memory. You route it there. Um, but maybe a request is about refund, or maybe the customer is frustrated, then you want to probably send it to another department. And if the query is about sales, right, you might want to just jump on the call. So you want to take another path and do a different set of actions there. So that's the in scenarios like this architecture is super helpful. Or maybe you have one agent that does bunch of stuff, it's internal use case or something, and then you just do bunch of routing stuff, where maybe you do one of these agent which does reasoning, the other agent it does coding, and the coding agent uses Claude, and the reasoning agent maybe uses R1. um, or Gemini thinking, and the other one which is just generic chit chat, summaries, quick rewrite, maybe a Gemini which is super cheap and still does good. That is helpful. Um, in cases like this, agent routing comes super handy yet. And at this point, LLM router, you can simply ask it to do the routing by giving it a JSON output, right? So you can make use of something like structured outputs. You get a JSON response, and then you can simply route it as you go. I'm gonna quickly show you an example, and then we're gonna jump into the coding. But before I do that, I'm gonna simply draw this in Excel draw. So let's say you have this user input coming in, right? And then you have your router agent, right? To make the decision, right? You say make decision, or this router agent, literally it can be simply a neural network as well, right? That does the classification for you. And once you have the classification, you know, hey, you need to route it to a certain part. You might not want to use maybe an LM for whatever reasons, right? And then this router agent sends it to next agent. Let's say we have this basic agent which does summary, right? And this agent does maybe reasoning, right? And it uses something like R1, and summary, this agent uses maybe Gemini, right? And then you have a coding part of it, right, for your agent. But for that, obviously, you wouldn't be doing Gemini or something other than Claude, right? Um, and then so this is what routing is gonna do for you. So you have all these dedicated agents, which does one thing. They're really good at them, and then you just route your input to the desired agent, and then you get the output. Um, and then this part, you can use something like structured output and ask it to give you output in a form, something like maybe hey, just tell me which agent to use. And then agent could be one of, and then you can just say, hey, give it an string, and where string can be an enum of the one of these types that you defined here, right?
Yeah,
uh,
yeah. Correct me if I'm wrong, but like, isn't this quickly becoming like an eval architecture, right? So LLM as a judge of sorts, right?
yeah,
A lot of people like over engineer the eval systems. I think simple, which is hard, but always works really, really well, right? So uh, you can have all the information in the prompt instructions, system developer instructions, whatever you want to call it. Let's just call it instructions for a very good LLM. Let's say O3 Mini High, which I generally use. You can give it all the information and the structure of how you want the output to be, like the name of the agent, just like in the structured output. In that, agent can decide based on the work, am I supposed to write code? Am I supposed to reason over data? Am I supposed to summarize something, right? And because the output of that agent is just going to be this small thing, it's going to be much more less costly than trying to do all of that with one agent, one really high quality LLM or a low quality LLM that might not really work, right? Go ahead.
yeah. Adding on top of that, this also helps you actually build a better scalable mental model, right? Because hey, you can go ahead and see how much your coding agent is being used, right? And what's happening in the reasoning, what type of questions are coming in there. So this isolation itself is actually helpful with respect to business value, right? Because you want to get those insight instead of dumping everything into one LLM call. Once you have all this nicely structured architecture, you can dive into each of those parts. You can optimize those, and you get the visibility in each of those parts. Say what kind of questions are coming into the coding, or if there are questions coming for the coding at all, right? And if you see, hey, model is not performing well on the coding, or maybe reasoning, then you can just go in and just change that one part instead of going and changing all of your things and moving all of those parts. you can just change that part. And as Ahmed showed you earlier, um, we have this nice studio where you can just go and click and change this LLM, and you can see the output there. Now imagine a setting where you have this whole system developed and running in the production, and your manager comes in and they're like, hey, this new model comes in, I want to try. They can just go ahead quickly, literally in the sandbox, they can just try it and experiment with it, or and then change it if they think it's good, without actually diving into the code and changing anything inside the code, which is really helpful. Not only in terms of collaboration, but also in terms of how the concerns are shared and how the stakeholders also get value out of it, and the developers, they keep developing without going back and forth and actually changing the code every time there is something new happening. Cool. And then now I'm gonna get back to the architecture example. Let's see. Okay. Cool. So the example that I just showed, we're gonna set up a routing system. Then we have three main agents: summary agent, reasoning agent, and coding agent. We're gonna use Gemini, DeepSeek, R1 obviously, and then coding 3.7, 3.5, 3.7, Claude, whatever works good for you. And then we're gonna run it through an example and see how it actually works. Um, Again, very familiar JavaScript code, agent configurations. First, we have the router agent. We are using as basic as Gemini here. Um, and then we have our system prompt where we tell, hey, these are the agents that you have access to, and we want the output in this form. And then just like we saw the summary agent and feature agent and marketing copy agent for the chaining architecture, similarly, they are defined here. Now we have a reasoning one, summary one, and the coding one. Each of them have their own specified model, which is specialized for that particular use case. Again, we are just creating the agents. This creating agent is just one-time thing. Um, Next, we just define the router agent usage. We're just running it, get user input, and then we parse it, right? Because we know the summary is going to look like one of these JSON things. We're going to parse it, and we're going to get actually the summary reasoning and one of those values. Um,
So this is the router part, right? If you can zoom in,
yeah,
this router is going to respond back with something like this, right? Uh,
yeah.
what is the model being used here?
For this example in the docs, we are using Gemini, but
Okay, I'll probably use something with maybe Gemini 2.5, which is really good, right?
yeah,
Or
2.5 is not good. I think we gotta update those examples now.
yeah. Maybe
Yeah,
it's an example anyway. But like
yeah,
I just wanted to quickly point out that anything that is making a decision, start with something that is super expensive,
yeah.
really high quality. Don't worry about cost. Don't worry about performance or speed or latency or anything like that. Build the best possible architecture, and then from top down start optimizing. Like, can I replace this small piece with this very fast LLM? Let's see how it does. Right? That's how I want people to think about building their agentic architecture. Go ahead.
Okay, cool.
So
Yeah.
we had built the summary agent and the router agent.
Okay. Sorry. Um, am I in the wrong one? Oh no, it's the correct one. Okay. So this is the router agent. Yeah, we just write this wrapper function to just do the run on this part and get actually nicely passed output. The main function just doing this one-time thing, create pipes. Uh, the user input that comes in, it goes through the router agent. We get the decision out of it, and based on that decision, we just select the agent and literally we just run it, and we get the final output. Nothing fancy going on here. Again, very powerful architecture, but very simple code, very basic, as you would do in any of the programming language. Now I'm gonna quickly run it here to show you the output. Okay, So the question that going in here is, hey, why the days are shorter in winter? The router decision comes in. It's a JSON which says, hey, we need to use it. It does the reasoning on top of the user query, and it decides, hey, um, we need to use the reasoning agent.
Can we
And
can we can we can we draw this? I think this it's
yeah,
complicated enough.
yeah.
Or can I do it for you while you explain? Uh,
Sure,
okay,
sure.
so
Yeah.
let me share my screen. So this is what has happened, right? So the user has sent an input, right? And the input right now is why days shorter in winter, right? So I'm just gonna probably put it here, right? This is the input, right? And this input has gone to our router, right? Oh,
I
I
think your
think.
screen is not showing.
Oh, there you
Yep.
go. Okay, so here's a user input. Why days are shorter in winter, right? This is going to the router, uh, and the router is a high quality agent, an agent with a high quality LLM. And the thing that router is going to do is it's going to understand what is being asked, right? So this is the work it is doing, right? So the question coming into it is why days are shorter, and it's not the job for this router is to figure out which agent needs to work on this particular input, right? So Sakib, correct me, how many agents do we have here? So one
We
agent
have
has
three.
this.
One is summary, other is coding. The third one is reasoning.
Yeah, so third one is coding, and then there's a reasoning agent. Obviously, reasoning agent will have an expensive reasoning LLM, right? Like O1 or O3 or something like that, like Deep Seek R1 or
R
whatnot.
one as well. Yeah.
Yeah, yeah. So here's the question that we send to the router. And router is going to make a decision, and it's just going to give us the decision, right? We are then going to pick that decision, parse it, and send the data to that agent. And the decision should be you should use this, this, or this, right? So now, Shakib, if you were to show your screen,
Yep.
or I
Uh,
can probably jump.
yep. It's here.
Okay, so now when you ran this, the router decision, if you could zoom in a little bit more,
Okay.
yeah. So the router decision that came back is maybe command B. Yeah, there you go. The router decision that came back is reasoning, uh, right? So what is happening here? The router is actually saying that for this particular thing, you should be using a reasoning architecture, right? Or the reasoning agent, right? Probably gonna show this on my screen anyway, right? So this is what's happening, right? This is what the output was from the router, right? So I'm gonna now move this down here. The output we have received from the router agent is reasoning. Now we're going to parse this and we're going to figure out like, okay, reasoning agent is what we got as an answer. We're going to read out this query, with simple JavaScript or Python, right? And we're going to then use the reasoning agent, right? So reasoning agent is going to get this as well now, right? So the reasoning agent will get why days are shorter in winter, right? Then the reasoning agent here will respond. Okay, well, here's the breakdown of why days are shorter. This, and this. Well, probably even don't know why days are shorter, so I'm getting pulled in by the text. But there you go. In simple terms, there this is pretty simple, right? Had this query been about can you write I don't know some function in TypeScript or something, right? We would have received back coding, right? And then we would have sent this to the coding agent, right? This is generally how the routing architecture works. You can very simply build a router, and it's beyond me how simple this is. You can just create an agent, and that agent, which I'm gonna quickly show you here, that agent is. You're just going to tell it what to do. It has to just have a really good LLM, right? uh, Again, start with a very expensive LLM here, and you're going to explain, like, your job is to make sure you can decide between this and this, right? So understand what the user is saying, reason over it, and tell us which agent we should use. And then always make sure you're responding in JSON and something, give it an example of what the output should look like, right? You can even go for a structured output here. Make sure that JSON property is on, and you're always getting a JSON output from this. Like, it again depends on an LLM. OpenAI has many fine tunes on many LLMs that are trained on structured output, right? So if you end up picking something like, I don't know, Llama 3 or Llama 2, it will probably not do that well on structured output, right? So make sure you're picking up the right LLM, experimenting when you're picking up an agent router, right? Um, Sakib, go ahead.
This stuff, I think we already this pretty much covered it really well. Our code is out there, and I think we're already over the time. I
Mhm.
was planning to cover some coding examples, but I think I'm gonna share it later on. Do we have any questions? I think we can take those and wrap it up.
Yeah, so I think I see a couple of questions here, right?
Yeah.
One question is from Sayed. Sayed is saying, how can I how can an AI agent perform zero shot casual reasoning in complex real world environments with noisy, incomplete, and conflicting data? And then I asked, like, what do you mean by noisy data? So he was like, in healthcare diagnostics, a system receives incomplete patient data from various sources like wearables, EHR, which I don't know what is EHR, but doctor notes, and must
Mm-hmm.
infer the root cause of an unknown condition it has never encountered before. So here's my answer, Sayed. You are gonna build multiple agents to do this, right? You're gonna build an agent that can understand what the doctor notes are saying. You're gonna build an agent that is going to understand what the data from wearable, the data that you're receiving from wearable. Maybe it's a, I don't know, a blood pressure machine or something, or multiple machines. And then I don't know what EHR is, so I'm not gonna go there. I'm not a doctor, right? You're gonna combine all of this data, and you're probably going to go this because it's healthcare. You're going to go with an LLM that is distilled or fine tuned for healthcare and that kind of data, right? Even if you don't, even if you go with a very high quality LLM, like something supremely good, like O3 mini high or O1, which is going to be expensive. But these are the biggest models, maybe even GPT 4.5. I don't know how well they will do. I'm sure Google has a bunch of palm models, which are actually distillations on a lot of health data. So you're going to have to experiment a lot, right? And you will instantly not try to make a diagnostic architecture. You will probably actually try to make this decision making process quick, right? You'll probably try and give a doctor or a nurse or whoever is the end user of this system more information easily, right? For example, a better example would be if there was an agent, there is an agent in my system that I've built, which is right now listening to everything Sakib and I am saying. And even though I was there, but I was also distracted by reading your questions when Sakib was speaking. So I can just go ask that agent now that did Sakib touch on this part or that part, right? And it will probably respond yes or no. This is already quite helpful for me, right? So when you're building something like this, so he's saying it's electronic health record. Okay, there you go. Right. Uh, the purpose of this analysis, I don't know what that is. Generally, you would want that purpose, especially because this is healthcare or critical information, to be judged by a human doctor while you are building this system, right? And you will make their lives easier. You will make it easy for a doctor or a nurse to say, "Do we have this data for this patient?" what were the patterns from last night till this morning or for last 12 hours, right? So instead of a doctor coming in and looking at all of those patterns in trying to analyze it themselves, maybe they have young doctors who are now joining the team. If there's an agent that can tell them like, this is what I picked up, they don't have to rely on that agent, but it's already very helpful to ask an agent to process a lot of or ask a workflow or a system of multiple agents, right, to work a lot of different data streams and provide a particular answer to a particular pattern. It will already become very very helpful, right? What you would not want to do is you would not want to build something that is like absolute, right? There's no absolute here, right? Where I'm going to build an agent architecture that will absolutely diagnose everything that is wrong with an agent. So it will be noisy, but it will help you analyze a lot, and it will help answer a lot of your questions, right? That is probably where you would want to use an agent, right? I hope that helps, right? Again, multiple agents, each agent probably trying to do one thing. One is looking at your electronic health record. Maybe the electronic health record is a lot of data, right? Again, I don't know if it is a lot of data. Maybe you have multiple agents. One agent is only concerned about the heart related health records. One is only concerned about something else, right? You want to make sure you have this joint architecture talking to each other, where multiple agents are analyzing multiple streams of data. And then obviously you will have routing, similar to what Sakib was talking about today. You will have a router that will figure out what you are asking it. Like, if you're saying, tell me more about what the, I don't know. Again, I'm missing the right terms because I'm not a doctor, but tell me about what the pattern was for his pulse rate. And then the agent router will figure out like, okay, so we need to talk to an agent that is built for analyzing the pulse rate. And maybe you have an agent somewhere in your system where it will pick that agent, and then you will run that agent, right? Again, these architectures become very very helpful in very very complicated complex situations like this, right? But what we have seen is there are only like 8 to 9 architectures that can that if you can almost build all any agent out there, right? Any complicated agentic architecture. Okay, I think that one was covered. There's another one,
Yeah,
Sakib.
I wanted to add a few things
Go
there.
ahead, go ahead.
Uh, I think memory would be really helpful to augment those pieces for doctors. As you mentioned, you need to identify that missing data. So one thing that LLM's really good at is just identifying patterns in text, right? So whether it's doctor's notes, whether it's doctor-patient conversation transcript, whether it's EHR or variables, what you can do is you can pull in all of those data in different agents, and then you can have dedicated agents who actually know and have knowledge about the medical stuff, right? And then that memory attached to them, you can ground your responses in that. And once, as Ahmed mentioned, the data becomes available to the doctor or to the nurse, they would not only be able to see it, they will also be able to read the sources around it. So that will bring more confidence in your solution, so you know where this thing is coming from and LLM is not hallucinating. So that one part is also critical in healthcare, that your LLM does not hallucinate. And then these architectures, and some of those basic principles, like getting LLMs to do just one thing and do one thing really well, that will be really helpful, along with the memory to ground your responses and reduce the hallucinations.
Awesome. And just to superimpose the memory part, there are so many different variants of memory. Uh, and when we say memory, what we mean is memory agents. Our memory agents come with vector stores in them. So every new memory agent has a new vector store in them. And you can have like, GBs, if not terabytes of data in each of those vector stores. So you can have multiple memory agents per patient or you can have one memory agent per patient if you wanted to, right? Again, even with memory agents, we give you the option to split up the data, right? So here's Ahmedabad's heart rates data in a memory agent, right? And memory in that data could be huge, right? That you cannot put into a prompt, right? So you would put that data there, and then that vector data could be searched through a similarity search algorithm that we have, where you just say, what was Ahmed's heart rate like? Uh, I don't know, last week or maybe in January. And if your data is really good in there, like it should be able to figure out that these are the chunks that are related to heart rate data for January, bring that into the prompt and use the LLM to answer that. Right? Awesome. I think rest of the questions, there was a question from, I'm probably going to butcher it, but Sadi, who's like, how can we manage multiple executions of parallel or conditional workflows, especially with tool execution? I shared an example there. So that's covered. There was one question about our SDK. Our SDK is definitely open source. Feel free to take a look. I think we are pretty much covered, right? There was one more question, and that was, can you take multimodal input or just text? Really depends on you. You can take any kind of input. You can like get the user to upload a file, parse that file. We have a primitive for parsing, chunk that data, and convert that into text. Right. If you have audio input, you can use something like from 11 Labs. You can use something from OpenAI for where which converts speech to text, and then that text is what you send to an agent, right? What else? I don't know if you can take a video input, but video input would be very similar as well. You would probably want to build a system that takes the video, transcribes it, and then uses both images and transcriptions based on what you're trying to build to answer users' questions, right? It can be as multimodal as you want it to be. Like Langbase is pretty open. You can integrate it with literally anything. It's like, we're like Node.js, and what you are asking are NPM packages. You can bring in anything, right? Our API is available for literally any language, right? So you can be writing code in Rust or Go or Python or whatever fits the bill for you. I think that's pretty much it. Sakib, do you have any ending thoughts?
Um, yeah. So I think over the time, one thing that I have learned is LLMs hallucinate. It's a fact. No matter which model you're gonna use and whatnot, what you can do is to use these basic principles to make them more reliable, right? Getting them to do basic things using architectures like routing, and some more that we're gonna share in the upcoming workshops. They are really, really helpful in actually making your systems reliable and dependable, and make sure they scale and they do not hallucinate at random points, right? And then getting LLMs to just do one atomic thing and then compose them together. So that's helpful. That really helps you build reliable and scalable agents in the longer run. That would be my takeaway from this.
Awesome. Well, this was pretty much a lot of fun. I am pretty sure we are a little bit, above time. Feel
Yeah.
free to go ahead, sign up. I just shared the link on the video here, and we have this new Discord server now. We are trying to hang out there. If you have more questions, you're building something. It's always fun to build it with the community. Come join us there, and we'd love to see what you are up to. We just found out a couple of customers are building like 400 agents per month on our platform, which is amazing. Our platform is scaling really, really well. Would love to have you all there. And yeah, that's pretty much it. See you next Thursday for our next workshop. We have now started to get in the habit of having one workshop or office hours every Thursday every week. And yes, this workshop, all of these meetups of sorts are recorded. They are always posted on our social media, especially on YouTube. Looking forward to seeing what everybody builds. See ya. Ciao. Peace.
I mean,